Today I want to show you how to create a simple game with flexible layout in Godot. Say you are designing a game for mobile in portrait mode. You will have to support a variety of slightly different aspect ratios. And let's also say you want to support running the game in a resizable desktop window. You could allow for a little more horizontal space in that scenario, but still want to keep everything essentially in portrait orientation. I'm going to demonstrate a solution using Godot's aspect ratio container with some dynamic adjustments. This may or may not be exactly what you need for your own projects, but hopefully this example can help you get a grasp of dynamic layout basics in Godot. At the end of the video, we will also make the game handle touch input and export it onto an actual Android phone. So let's get started. Create a new project. In the project settings, set the base resolution to 720 by 1280. Make the window resizable with stretch mode set to canvas items and expand. Also set the handheld orientation to portrait. These are the recommended mobile portrait settings as mentioned in the Godot docs. Now onto the main scene. Pick user interface to create a root node of type control. The anchor presets should already be set to full rect by default. Add a color rect child node, set the anchors to full rect as well and give the control a dark background color. This is going to be the background showing left and right of our play area when the window becomes too wide. And don't forget to save the scene, we will simply call it main. There are only going to be a few simple scenes in this project and no assets at all, so I'm not bothering to create folders this time. Now create an aspect ratio container and set the anchors to full rect. Make sure stretch mode is set to fit and the alignment options are set to center. Add another color rect as a child of this container. This is going to be our actual game area. Give it a background color of your liking. As you can see, by playing with the ratio setting of the container, we can constrain this color rect to different aspect ratios, filling the viewport either vertically or horizontally. We are now going to dynamically adjust the ratio from code, so the value in the inspector doesn't actually matter at all. Attach a new script to the scene's root node. The first thing we need here is a variable to define the widest aspect we are allowing. I'm marking this an export variable so it can be conveniently changed in the inspector later. Control drag the aspect ratio container node into the editor to create a reference variable. Now let's define a function to set the container's aspect ratio from the actual viewport size. The aspect is just the viewport's width divided by height. In case the viewport becomes too wide, we are limiting the aspect to the maximum value we've defined above. All we have to do now is setting the ratio property of the container to the resulting value. When we call this function from ready and run the game, we find that the game area initially fills the window precisely. When resizing, the aspect doesn't adjust though. To handle dynamic resizing, we connect a handler to the resized signal on the root node. In this handler, we simply call setAspect again to recompute the desired container ratio. A minor thing to watch out for here is that the resized signal is sent before ready, which means that none of our onReady variables are defined yet and we will run into a crash on startup. So we add a check here to call setAspect only when the node is ready. If we run this again, we see how the game area is now becoming a little wider as we are resizing the window, but is still limited to overall portrait dimensions. Let's now add the bat to the game, which is going to be player controlled. Create a new scene. This time pick 2D scene to create a root node of type node2D. the bed is going to be a simple block of color. Create a color rect and call it bar. Set the size to around 100 by 20 pixels. This color rect is a control, but since it is not a child of another control node, no automatic layout is happening on it. So we can ignore the anchor settings. Instead, we are going to compute the dimensions in code now. We want to size and position the elements of the game relative to just the game area portion of the viewport, which also changes in aspect dynamically. The available automatic stretch modes in the project settings aren't quite sufficient here. Instead, we will think of the game area as having a normalized size between 0 and 1 in either dimension and express everything based on that, resolution independent. We will adjust all the resizing and positioning ourselves in code. Actually, we could even set the stretch mode in project settings to disabled. And I invite you to play with that after you finish this tutorial. Figure out what difference the various settings make. Add more elements to the scene and see how they move and resize. For now, let's leave everything as is and move along. Attach a new script to the root node. We want the bed to be sized relative to the game area width. So I'll create a variable for that. A value of 0.2 means the bed is going to fill 20% of the available width. We are also going to need a reference to the bar color rect, so drag that in too. Another variable is tracking the position of the bed, also in normalized coordinates between 0 and 1. The initial value positions the bed centered in the lower half of the game area. Speaking of the game area, we need to let the bed scene know how large that actually is. Here I'm using a property setter. Every time the value is set, we are going to compute the position and dimensions of the bed rectangle. We are later going to set this property from the main scene whenever the size changes. In this function, we size the bar by simply applying our bed width fraction to the pixel size of the given area. I'm setting the height of the bed rectangle to always be 25% of its width. To center the bar rectangle relative to the scene's root node, we simply offset it by half the size. And finally, the pixel position of the whole object is just the normalized position scaled by the area size. Let's put the bed into the game. Switch to the main scene and drag the bed scene into the tree, as a child of the game area. Position it anywhere you like, it doesn't really matter, we're overriding this in code anyway. Now switch to the main scene script view. Select the game area node and connect a handler to the item rect changed signal. In this function, we pass the rectangle occupied by the game area to the bed node. You may be wondering why we don't do this from the existing resized handler. The problem would be that the game area isn't necessarily updated at this point. For example, at startup, the game area rectangle is still empty. So it's better to react to the actual rect change on the game area element itself. Running what we have so far, we see that the bed is placed and sized correctly, following the size and aspect of the game area. Now let's add player input to move the thing around. Switch over to the bed script. Add an export variable for setting the movement speed. This is relative again, the width fraction covered per second. So 0.5 means it takes 2 seconds to move from left edge to right edge. In process, we check for input using the predefined UI left and UI right actions. They are mapped to the cursor keys by default. We apply the move speed, scaled by delta, to the normalized position of the bed. To avoid going past the left edge, we stop when x, which marks the center of the bed, equals half the bar width. Likewise, we reach the right edge at 1 minus half the bar width. After updating the position, we simply call calc bed rect again to update the actual bar position. It's not really necessary here to update the size every time, but I'll leave that optimization to you. Now we can move the bed properly within the confines of the area at any window size. And that's pretty much it for the bed. Let's move on to implementing the ball. We set this up very much like the bed scene. Create a new 2D scene and call it ball. Again, add a color rect as a child node. Attach a new script. We add a variable which expresses the size of the ball as a fraction of the game area width. Rename the color rect to dot and Ctrl drag the node into the editor to create a reference variable. The code to calculate size and position of the ball is very similar to what we did for the bed, with the exception that the dot is square. No surprises here. Switch back to the main scene and drag the new ball scene into the tree next to the bed node. We still need to give the ball an initial position. Let's add that now to the script. I'm creating an extra function for initializing the position here because we are going to call this again every time the ball goes out of bounds when it moves past the bed. For now, we just call it from ready. Lastly, we have to pass the game area rect again, same as for the bed. Let's see how this looks. The ball is a little small. I will double the size. So, ball and bed are sized and positioned correctly now. The last step is to set the ball in motion. This is going to be the most complex piece of code in this example, but I'll make it as easy as I can. Our ball is going to move at constant speed, moving only at 45-degree angles. We want it to bounce off the balls and off the bed at 45-degree angles as well. First of all, we'll set up a variable for the ball's speed. Next, we need a velocity vector. This is initialized together with position. The ball is initially moving upwards and to the left. Now the actual movement code. In process, we compute a new position by applying the velocity vector scaled by delta to the current position. To keep the ball precisely within the confines of the game area, we need to know the size of the ball in our normalized coordinates. Note that this normalized size is typically not square, but will follow the aspect of the game area. Now we can simply clamp the new position to the maximum and minimum allowed position. Almost the same as for the bed, but in 2 dimensions. After updating the position, we can check for wall collision by comparing the clamped and the unclamped values. If they are different, we have hit one of the walls. And in that case, we invert the corresponding velocity vector component. Finally, update the ball rectangle and we should be ready to go. As you see, the ball bounces off precisely at the boundaries of the game area. But we can't deflect it with a bat yet. Let's add that to the script. So when the ball is moving downwards, and assuming we have some function on the bat for hit testing, we check if the bottom center of the dot is colliding with the ball. And if so, we deflect in the y direction. 2 things are missing here. First, the ball needs a reference to the bat. I'm adding another property with a setter. The setter isn't really needed here, and making game objects depend on each other like this is questionable anyway, but I'm trying to make this tutorial as concise as possible, so please forgive me the design flaws. The bat doesn't have a class name yet, so let's quickly add that. In the main script, we pass a reference to the bat onto the ball. The other remaining task is implementing the hit test. This one is really simple. Given a point in global coordinates, we convert it to the local coordinates of the bat and use the hasPoint function of the bar rectangle to check against the point. We should also check if the ball went past the player. This is where you would decrement a ball counter and display game over when it goes to 0. I simply reinitialize the position here. And with that, our game is complete. You could now go and adjust difficulty, display a score, implement a ball counter and a game over screen and so on. But before you run away and have fun with that, let's quickly have a look at how to get this game onto an actual Android phone. I won't go into setting up the Android SDK, etc. This is all very nicely documented in the Godot documentation. In the end, your editor settings export Android section should look like this, with paths to the Android and Java SDKs and key store credentials. You can then go to Project Export, add the Android preset and build an APK. But before we do that, what is missing? Touch support. Adding that is fortunately very easy to do. Godot provides a touchscreen button class that maps touchscreen events to input actions. In the main scene, add a touchscreen button node and call it left button. Add a rectangle shape to the button. Give it a size of roughly 300 by 400 pixels and move it into view. This doesn't matter all that much since we are going to resize and position these buttons in code in a moment. Assign the UI left input action to the action property. Now duplicate this button and rename it to right button. Move it to the right of the other button and change the action property to UI right. Switch to the main script. In our setAspect function, we resize and position the buttons so they occupy the lower left and right quadrants of the viewport. That means the size is simply half of the viewport size in either dimension. This needs to be assigned to the shape of the button, which we know is a rectangle. All that is left to do is positioning the buttons again based on the viewport rectangle. Of course, touchscreen buttons aren't usually visible unless you assign an image texture to them. To check if our size calculations are correct, we can enable visible collision shapes from the debug menu. Now we can see how the buttons are laid out. Okay, we are ready to export the APK. When you made the build, copy the APK onto your phone and install it. And there it is, a very simple mobile game with adaptive layout. I hope you found this tutorial helpful. UI layout can get pretty complex and there isn't a one-size-fits-all best solution for everything, so play around with this application, extend it, try to find different solutions for your needs. And above all, don't forget to have fun making your own games. Hope to see you around for the next tutorial. Until then, bye!